All right, welcome to Foundations of Math 30. This is outcome 30.05, 05, lesson 5, conditional probabilities with tree diagrams. So in the last lesson, we did talk about this formula, but we kind of got away without using it. We're going to have to use the conditional probability formula, which is probability of B given A is equal to the probability of A and B divided by the probability of A. And we're going to use a tree diagram to do these, okay? So we're going to actually do example number 1 and example number 4 together, or problem number 1 and problem number 4, and then you're going to work through the remaining ones together. So problem number 1 says, Miguel remembers to set his alarm clock 72% of the time. Okay, so he sets his clock 72% of the time. When he does remember to set his alarm clock, the probability that he will be late for school is 0.1. When he does not remember to set it, okay, when he does not remember to set it, the probability that he'll be late to school is 0.7. I'm telling you that Miguel was late today. There's my conditional probability. I'm telling you he's late. Determine the probability that he remembered to set his alarm clock. Okay, so I'm going to create a tree diagram. So basically what I've got is two situations. Either he sets his alarm clock or he doesn't set his alarm clock, right? So he sets it or he doesn't set it. Now, the probability that he sets his alarm clock, it says he remembers to set it 72% of the time. That means the probability is 0.72 that he sets it. And then not setting it would be the rest of the time. So that would be 28% or 0.28. Now, this is why it's called a tree diagram, because there are two branches off of that. If he sets it, he can either be late or he can be on time, right? So he can be late or he can be on time. And if he's late, it says that he is late 0.1% of the time when he sets his alarm clock. Well, then he'd be on time 90% of the time, or 0.9, right? Same thing when he doesn't set it, he can either be late or he can be on time. And it says that when he doesn't set it, he's late 70% or 0.7, which means he'd be on time 0.3. Okay, so what we want to know is we want to determine the probability that he set the alarm clock given that he was late today. So the formula is then the probability that he set it and he was late divided by the probability that he was late. The one that's second goes on the bottom. Okay, so the probability that he set it and he was late. Well, if we look at our diagram, this is the branch of the tree that says that he set it and he was late. So set it and late means we need to multiply those probabilities together because the word and means to multiply. So the probability that he set it and he was late is 0.72 times 0.1, which is 0.072. Okay, so I know that the probability that he set it and he was late is 0.072. Now, what is the probability that he's late? Well, there are two options for being late, right? So there's two options for being late. He could either have set it and been late, or he could have not set it and been late, right? So to determine the probability that he did not set it and was late, we want to follow this path where he didn't set it and was late. So that is 0.28 times 0.7, which comes out to be 0.196. Okay, so our options is he can be option A or he can be option B. And we know the word or means to add. So I need to add together 0.072 option 1 plus option 2, which is 0.196. Okay, so when I do that, I get 0.072 divided by 0.268, which equals 0.269. Okay, we are going to move now to example number 4. All right, here's example number 4. It's actually a little bit easier than the first one, but we'll go through that. It says Hillary is the coach of a junior ultimate team. Based on the team's record, it has a 60% chance of winning, I should say winning on calm days, and a 70% chance of winning on windy days. That's actually a little bit better chances of winning on the windy days. Tomorrow is a 40% chance of high wind. There's no ties. What is the probability that they're going to win tomorrow? Okay, so basically what I've got here is it can be windy or it can be calm, right? And on the day in question, it says that there's a 40% chance of high wind. So that's 0.40 chance of wind would mean 0.60 chance that it's going to be calm. Now, when it's windy, they can win or they can lose, right? So we've got two branches coming off of that. We can win or we can lose. And when it's windy, they have a 70% chance of winning, so 0.7, and a 0.3% chance of losing then, or 0.3 probability of losing. When it's calm, you can win or you can lose. When it's calm, there's a 60% chance of winning, so that'd be 0.6, and the remainder making up the 1 goes there. So what is the probability that they will win? Okay. Well, this isn't actually a fancy conditional probability question. It's just the probability that they will win on this day when there's a 40% chance. So basically, it's windy today. We're on this branch and we're going to win. So my probability is 0.4 times 0.7, which is 0.28. Okay, simple as that. So I want you to go ahead and practice with some of these tree diagram questions. And if you have problems, just ask.